Hey guys, gonna go over the 6.11 homework. So here we go. The function f has a continuous second derivative. The table gives values of f and its derivative f prime at select values of x. What is the value of the integral from 1 to 2 of x times f double prime of x dx? So you might be looking at that and being like, what the heck? This right here is gonna, so 6.11 was integration by parts. So we're going to evaluate this by doing integral by parts. And so let's go ahead and do that. So I'm gonna identify two parts. One's gonna be u and one's gonna be du. This x has got to be u, and this right here has got to be dv. This is easier to integrate. This will be easier to, well, they're kind of both. You could probably do either, honestly, here, but I think I'm going to stick with that right there. So integration by parts, since we're saying u is equal to x, and we're saying dv is equal to f double prime of x dx. Oh, man. I wonder if we can, yeah, I'll just go with this right here. Du dx will be equal to 1. I'm just going to call this du is equal to dx, because we want dx on the right side. And then v will be equal to, well, the integral, the antiderivative of f double prime will be f prime of x. And so we're going to have this right here, this integral is going to be equal to u times v, which is x times by f prime of x, so u times v, minus the integral of v, which is f prime of x, times by du, which is dx. And then, so this is going to be equal to x f prime of x minus, and the antiderivative of f prime of x is going to be f of x. And this will be evaluated from 1 to 2. So then we'll plug in 2. We'll get 2 times by f prime of 2 minus f of 2. And then minus, now we have to plug in 1. So that's going to be 1 times by f prime of 1 minus f of 1. So 2 times by f prime of 2, which is 4, minus f of 2, which is 1, minus, and then f prime of 1 is going to be 2, so minus 2 plus, and then f of 1, which is negative 2. So we get 8 minus 3 minus 2, so 8 minus 5, which is going to be equal to 3. Okay. All right, so integration by parts. Let's go ahead, and I see this natural log. Typically, if you see a natural log with an algebraic, you want the natural log to be u, and you want the rest of it to be dv. So let's let u equal the natural log of x. The reason being is that the natural log of x doesn't have the best antiderivative, so you usually like to take the derivative of that. And so dv will pick to be 9x squared minus 4x plus 1 dx. Du dx will be equal to 1 over x, but then I'm going to multiply by dx, so du is going to be equal to 1 over x dx. And v is going to be equal to, so find the antiderivative, that's going to be 3x to the power 3 minus 2x squared plus x, right? So that's going to be 9x squared for plus 1. Okay, so then this will be equal to the integral from 1 to 2 of u times v. So that's going to be 3x squared minus 2x squared plus x times by the natural log of x, then minus the integral of v du. Now when I multiply 1x dx by all of this right here, when I multiply 1x by this right here, I can just divide all of these terms by x. So if I times this by 1 over x, which is what I'll be doing, that can distribute to all terms, but then I'm just dividing by x at that point. So that's going to become 3x squared minus 2x plus 1, and then dx. Gosh, I did not give a lot of room here, did I? Wait. That's not right there. There we go. So then we have 3x squared minus 2x squared plus x times by the natural log of x, and then minus, and then anti-differentiate this. This is going to be to the power 3 and divide by 3. So minus x to the third minus x squared, and then plus x, I believe. And this is going to be evaluated from 1 to 2. Okay, oh my gosh. Let's plug in 2. So that's going to be equal to, I'm sorry, I'm just using my calculator, man. Alright, so if I plug in 2 into this spot right here, 3 times by 2 squared minus 2 times by 2, well, what the flip? One second. That's a 3 right there. Okay, plug in 2, so it's going to be 3 times by 8 minus 2 times by 4 plus 2. So I get, hopefully, 18. So, get 18 natural log of 2. Okay, I'm seeing that here in a couple of them, so I think that's right, hopefully. And then minus, I gotta plug in 2 for these ones right here. So if I plug in 2, that's gonna be 8 minus 4 plus 2. So that's gonna become minus 6. Okay, and then we have to minus, now we gotta plug in 1. Now if I plug in 1 here, this becomes 0, and that just becomes 0. Then I just have to plug in 1 here. So then minus, so we have 0. We got the 0 because when I plug it in here. And now I have to plug in 1 here. So minus 1 minus 1 plus 1. When I plug in 1 into all those. Hold up. I gotta be careful with my parentheses right now. Okay, so when I plug in 1, for all of this, this becomes 0. So I get minus 0 minus 1 minus 1 plus 1. So I get 18 natural log of 2 minus 6. Now all of this, that becomes 0, that becomes plus 1, becomes minus 1, becomes plus 1. So I think it becomes plus 1, which becomes minus 5. So I think we should get A. I hope so. That was confusing. Okay, for these right here, using integration by parts, some might be easier using tabular method. I think a lot of these will be easier using tabular method. So like 3 and 4, definitely easier using tabular method because we have algebraic expression, trig, and e to the x. And so I'm just going to use the tabular method. So make a quick column. We're going to have 3x on the u side, and we'll have e to the 2x on the dv side. On the u side, we differentiate, and then on the e side, we anti-differentiate. So that'll be 1/2 e to the 2x, and then 1/4 e to the 2x. And then we kind of do like a crisscross, where you start here, go here. This is going to be a positive multiplication. This is going to be a negative multiplication. So this will come out to be equal to, this will be equal to 3 over 2x e to the 2x minus 3 over 4 e to the 2x plus c. And that should be it right there. If you need to check, remember that you can do the derivative here and it should come out. Just make sure that you use the product rule on this piece right here. But yeah, it should come out to be that right there. Should I check it? Sure, let's do a quick check. So the first times by the derivative of the second plus the derivative of the first times by the second, right? And then minus, and then if I do the derivative of this right here, it's going to be 3 over 4 e to the 2x times by 2. Now this is going to be, so it's going to be equal to, so first start with this piece right here. That's going to be 3 over 4 x e to the 2x and then plus 3 over 2. Oh, wait a minute. Hold up. I think I forgot the chain rule. I'm going to start from the beginning. So we do the first. So I'm taking the derivative of this. So I do the first, which is 3 over 2x times the derivative of the second, which would be e to the 2x times by 2 for the chain rule. So I do the first times the derivative of the second plus the derivative of the first, which would just be 3/2 times the second. So I think that's all for the derivative of this first part. I just use the product rule. Then minus 3 over 4 e to the 2x times by 2. And then this right here becomes 3x e to the 2x. And then this will multiply, and that will reduce that to be 2, which will then just cancel out with that right there, leaving me with 3x e to the 2x. So checks out. Okay. I almost messed up the derivative in trying to prove that that's right, which would be scary because I was right, but then if I mess up the derivative, it would have led me to believe that I was wrong. But anyways, it happens. Alright, I'm going to use tabular method here. So starting with x squared for u column, derivative is 2x, then 2, then 0, and then cosine of x, we're going to do the antiderivative, which should be sine of x, because the derivative of sine is cosine, then negative cosine of x, then negative sine of x. So let me go backwards here to make sure that I got these right. So the derivative of sine is cosine, but then we got the negative. Derivative of cosine is negative sine, but then we got the negative, which returned it to positive sine. Derivative of sine is cosine. And then that's positive, that's negative, and positive. So this will come out to be x squared sine of x, then minus 2x, no, plus, because we have this negative and that negative. So then plus 2x cosine of x, then minus 2 sine of x plus c. And I do not want to check because I have to use the product rule here twice, but I'm sure it's good. Alright, okay, here, I think I'm not gonna do tabular method here. Okay, so we're going to do u as the natural log of x and x dx as v. So u is equal to the natural log of x, which means du will be equal to 1 over x times by dx. And then we're going to say dv is equal to x dx, which means that v is going to be equal to 1/2 x squared. So then we're going to get u times v, which is 1/2 x squared times by the natural log of x, minus the integral of v du, which is 1 over x dx. And this right here is going to simplify to just be x dx. So I'm just going to call it 1/2 x dx. And the antiderivative for this right here, so we get 1/2 x squared natural log of x minus, we have to raise the power, so it's going to be that should be minus, I think that's going to be 1/4 x squared plus c. Okay, and then if we do a quick check right here, so the derivative here is going to require the product rule. So we're going to have the first times the derivative of the second plus the derivative of the first times by the second. And then the derivative of that is going to be 2/4 x, which is 1/2 x, right? So minus 1/2 x. And so here, I'm going to get 1/2 x plus x natural log of x minus 1/2 x. And those are going to cancel, leaving me with what I had from above. So we're good. Okay, for here, yeah, I'm going to use tabular method here. So 4x plus 5, and then e to the negative x. So the derivative here is 4, and then 0, and the derivative here is negative e, the antiderivative is negative e to the negative x, and the antiderivative there is e to the negative x, plus and minus. So then this will be equal to 4x plus 5, negative, and then e to the negative x, minus 4 e to the negative x plus, not plus c, this time it's going to be from 0 to 2. So if I plug in 2, that becomes 8 plus 5, which becomes, so we'll have negative 13 e to the negative 2. Then we have to plug in 2 there, so minus 4 e to the negative 2, then minus, and we got to plug in 0. So if I plug in 0, I'm just going to get negative 5 e to the 0 minus 4 e to the 0. So these can combine, and that's going to become negative 17 e to the negative 2 minus, or I guess I can say plus, because this will be minus 9 e to the 0, which would just be minus 9, so plus 9. I think that should be good right there. In my calculator, let me go ahead and put this in my calculator. So negative 17 e to the negative 2 plus 9. So that's equal to 6.6999300. And then in my calculator, let me also do the integral from 0 to 2. And let's do 4x plus 5 e raised to the negative x dx. And I get the exact same thing. So I just verified in my calculator. I just put this into my calculator right there, and I got the exact same thing as that. So looks good. Okay, and then for 7, yeah, I'm going to use a tabular method. So with 18x on the u column, and then cosine of 3x right here, so that's going to be 18 and 0 this is going to be 1/3 sine of 3x, and then this will be 1/9, negative 1/9 cosine of 3x. I think that's right, because the derivative of negative cosine will be positive sine divided by 3, because, or times by, if I times by 3 for the derivative, that will reduce to 1/9, and the derivative of sine is cosine times by 3 for that 1/3, and that will get rid of that. So, okay, so it checks out. That right there is going to be plus, this is going to be minus. So here we'll get 18 over 3, so that would be 6x sine of 3x, and then plus 2 cosine of 3x plus c. Okay, and I think that should check out. If you want to check the derivative here, make sure it's that right there, go for it, but I think I'm going to call it.